Glendale Community College. We are here to talk about energy. So, energy is officially defined as the capacity or ability to do work and transfer heat. So, heat is a form of energy. So, let's talk more about heat. It always flows from a high temperature down to a low temperature. Heat flows from hot to cold, is something we say. Let's think about holding a piece of ice in your hand. So your hand is at a higher temperature than the ice. So heat flows from hot to cold. So heat is going to flow from your hand to the ice. And that's why that energy going into the ice melts it. So heat transfers from your hand to the piece of ice and it melts the ice. So, forms of energy. There are many different forms of energy. You've probably heard of potential energy and kinetic energy, but there's also thermal energy, which is heat, radiant energy, that's light, electrical energy that we use to charge our cell phones. There's nuclear energy at a nuclear power plant. There's nuclear energy in the nucleus of an atom stored there. So let's talk a little bit more about potential and kinetic energy. Potential energy is the energy that is stored, or sometimes it's called the energy of position. Like if you hold a book up high, it has stored or energy of position because when you drop that book, it moves through the air and lands on the ground. So let's talk about in chemistry what we mean by potential energy. Well, that's the energy stored in atoms and in the bonds that hold atoms together. It's the electrostatic attractive forces between the ions as well in an ionic bond. It's what holds a +1 ion to a -1 ion in that bond. It's also the attractions between protons and electrons. Protons are positive, electrons are negative, opposites attract. So the attractions between those in an atom also have potential energy. Now, kinetic energy is the energy of motion. As atoms and compounds move, they have kinetic energy. Also, the bonds in an atom can rotate or vibrate in and out like a spring. That also counts as kinetic energy since it's the energy of motion. All right, here's something you need to know from this chapter. The first law of thermodynamics. Remember this. The first law of thermodynamics states energy cannot be created or destroyed, which means energy is conserved. So we can't just create energy from nothing. Otherwise, that would solve our energy problems, right? I mean, we go to wars over energy. Energy is important to us. We can't live our current lives without energy, but we can't create it from nothing. So energy cannot be created or destroyed. Energy can be transferred from one form to another. So we can have the energy stored in chemical bonds come out in a reaction like a combustion reaction where it lights something on fire. And then we get that energy and heat and light from the fire. So energy can be transferred from one form to another. It can be potential and you can turn it into kinetic, for example, when you drop a book. So the energy in and the energy out has to balance. It is conserved. What are the units for energy? Because we can put a number and measure energy, right? Well, the SI unit, which is the Systems International unit, is joule with a capital J. What you're probably more familiar with is the calorie. Like when you go for a run, you may say you burned 250 calories because you ran for an hour. Or you may think of food. You ate a Snickers bar and that was 222 calories. So a calorie is the amount of energy it takes to raise 1 gram of water 1 degree Celsius at typical air pressure of 1 atmosphere. So the amount required to raise 1 gram of water 1 degree. A gram of water is just a little bit of water. It's not a whole lot. And 1 degree isn't a whole lot. But that's the definition of 1 calorie. Now, 1 calorie is actually 4.184 joules. In science, we tend to use joule as our unit of energy and heat. It's important to know that the calorie is not a typical food calorie, by the way. A food calorie has a capital C to differentiate it. So it's actually 1,000 normal calories equals 1 capital C food calorie. So in science, when we talk about calories, a Snickers bar is not 222 calories. That's food calories. It would actually be 222,000 normal science calories. All right, we're going to come back and talk about where our energy comes from. See you in a minute, GCC. Have a good time. See you later.